All right, let's talk about something that could fundamentally change our entire electric grid. We're going to dive into a new system architecture, one that's actually inspired by the internet, and it's all designed to make our grid smarter, greener, and a whole lot more efficient. It's called price-based grid coordination. Our whole world runs on electricity, but the way we make that electricity is going through this massive transformation. We are shifting big time from old school power plants to renewables like wind and solar. And that leads us to the billion-dollar question. Our grid, the one we have right now, it was built for a totally different time. So can it actually handle the tricky nature of renewables? Where the sun isn't always shining and the wind isn't always blowing? That's the real puzzle we have to solve. So let's really break down what that challenge looks like, piece by piece. This slide just lays it out so clearly. On the left, that's the old grid. Think big centralized power plants that you could pretty much turn on and off like a light switch. Simple and predictable. But the new grid on the right, it's a whole different beast. It's spread out, with power coming from millions of places. Solar panels, wind turbines, that are changing all the time. Now, we have tried to adapt. You've probably heard of time of use pricing, right? Where power costs more in the evening. But here's the problem. Those are just fixed, kind of dumb schedules. They can't react to a grid where the cheapest, greenest power might pop up at 2 a.m. because the wind is howling, or right in the middle of a sunny afternoon. They're just too slow, too rigid for this new world. Okay, so we need a totally new way of thinking. And this idea, coming from researchers at Lawrence Berkeley National Laboratory, it's beautifully simple. It's called price-based coordination. Get this, the whole concept is inspired by the internet. Think about it. The internet has a simple interface that separates the insane complexity of the global network from, your laptop. This system does the same thing, but it uses price as that interface. This is genius because it lets the grid get more complex on one side and our smart homes get more complex on the other, and they don't have to know the messy details about each other. And the absolute key to making this work is something called a highly dynamic price, or HDP. Just think of it as a live feed from the grid. Instead of a price that changes maybe once or twice a day, this price can change as often as every 5 minutes. It's a real-time signal telling your devices exactly when power is cheap and green or when it's expensive and dirty. So how does this all actually fit together? Let's take a look at the architecture of the system and meet the key players that make it all happen. Now, this diagram, this is our map for the whole thing. I know it might look a little complicated, but it's really just showing how information, that all-important price signal, flows from the big grid on the right all the way down to a single smart device in your home on the left. Okay, so over on the grid side, you've really only got 3 main players. First, there's the retailer. That's basically your utility company. They create the price. Then you have GHG analysis, which might come from a service like WattTime, telling you how clean the energy is. And finally, the price server, which is like a radio tower, broadcasting all this info out into the world. Now, who's listening to that broadcast? Any device that can be flexible. The official term is a distributed energy resource, or a DER. It sounds super technical, but it's really just a fancy term for things you either have now or will very soon. Your smart thermostat, your water heater, your electric car charger, maybe a home battery. So in your house, that price signal can reach your smart device in a few different ways. It could go right to the device itself, or maybe to a smart hub in your house. It could even go to a third-party cloud service, like, say, the company that runs your thermostat, and they send the command down. The point is, there are a bunch of pathways for this intelligence to flow. It's flexible. So that's the theory, right? But what does this price signal actually look like when it's working? Let's talk about the price stream. And the researchers came up with the absolute perfect analogy for this. Think about it like you're streaming a movie on Netflix. Your TV isn't just getting one chunk of data. It's getting a continuous, nonstop stream of information. That's exactly what this is for energy prices. So what's actually in that stream? Oh, it's a goldmine of useful information. Your device gets to see a forecast of future prices, so it knows, hey, power's going to be super cheap in 2 hours. It sees the greenhouse gas emissions, so it knows when the energy is greenest. And it can even get emergency signals to help out the grid if there's a problem. Let's walk through a real-world example just to make this crystal clear. Picture your smart air conditioner. It's looking at the price stream and sees that electricity is going to be dirt cheap and super clean around noon, when all the solar panels are cranking. So what does it do? It pre-cools your house then. Later, at 6 p.m. when everyone gets home and prices spike, your AC doesn't have to blast away. It can just coast. You stay perfectly comfortable, you saved money, and you used cleaner energy. It's all automatic. Okay, so now take that one little example and scale it up. Multiply it across millions and millions of homes and devices. When you do that, you start to build a totally different kind of grid, one that's smarter and way more responsive. And the impact is just huge. The grid itself becomes way more stable because demand can automatically flex to meet supply. You, the consumer, save money. We can bring way more renewable energy online because we finally have a smart way to use all that power when it's available. It all adds up to a cleaner, cheaper, and more reliable energy future for everyone. And I want to be really clear, this is not just a theory in a lab somewhere. This data model, this price stream, is actively being written into the core technology standards that all the big manufacturers use. This makes sure that a smart thermostat from one company can speak the exact same language as an EV charger from a totally different company. They're literally building the universal language for the future grid. And that really brings us to the final thought here. The same way our homes got ready to stream movies and music, they are now getting ready to stream the price of energy. It's a whole new kind of data feed. So the real question is your home ready for that future?